Okay, cumulative for distribution function. So again, see, this one is your CDF, okay, which is your capital F. Okay, the same thing in discrete, capital Fx, the same symbol, which is probability x less than or equals to x. Okay, but again, this one is a continuous random variable. So that means we need to integrate from minus infinity up to x ft dt. Okay, so why we have here is different variable because you want to substitute x values. So normally we use in terms of writing in mathematics punya concept, we will replace it. So ft dt. So again, if you solve this one, at the end you will get your capital Fx. Okay. So again, if we have x between a and b, okay, normally what we did is we do integration a up to b fx dx. But when you integrate small fx, you get back your capital Fx. So you just substitute AB. So you will get this one, FB minus FA. So that one is called as definite integral. You already learned in calculus. Okay, integration AB, small fx. This is your PDF. Okay, this is your CDF, the relationship. So that means if you have capital Fx, you differentiate with respect to x, you will get back your small f. Okay, this is your PDF. Okay, you differentiate your CDF, your capital F, you get back your small f, which is your PDF. Okay, so let's say we have 3 over 8 x squared, 0 up to 2. Okay, so you want to find your capital Fx. Okay, capital Fx is your CDF in this case. Okay, so when we want to construct your capital F, okay, so you need to check the range. So range now is 0 and 2. Okay, so the same thing, capital F in discrete is your total probability, which is probability x less than equals to x. If you have, let's say, you have your x and then this one probability, yeah. So you have 0, 1, and 2. So that means if you want to find capital F2, you will have probability x less than equals to 2. So x0 plus x1, x2. Okay, so the same thing for concept for continuous. Okay, but we deal with a range. Okay, for capital F, you want to find capital F, you need to consider the range. So what happens when x less than 0? Okay, when x less than 0, what is your capital Fx? So that means, katakan we have the starting value for discrete is x equals to 0. So what is the value for F0? So F0 is the same thing, probability x less than equals to 0. So you get the probability. So the same thing, we need to consider what happens when x less than 0, the smallest value. Okay, for your Fx, okay, your range only defined between 0 and 2 for 3 over 8 x squared. Otherwise, it should be 0 density. So that means your capital Fx from minus infinity, okay, up to x is just 0 density function, which is 0. Okay, yang ni kita ambil ni. Okay, dia hanya define between 0 and 2. Otherwise, it should be 0. So we need to consider the range. What happens when x less than 0? So capital Fx, okay, we use the concept minus infinity up to x, 0 dt, which is 0. Okay, so the next one. Okay, kita tulis je macam ni. Okay, but again, your capital Fx. Okay, so that means we will have minus infinity, hasil tambah Okay, the same thing macam discrete, minus infinity, up to 0, we give a value, 0 dt, plus 0 to some value of x, okay, 3 over 8 t square dt. Okay, kita tulis dulu 3 over 8 t square dt. Again, here, you will have, apa tadi? 3, so 3 over 24, t cube, Okay, 0 up to x. So that's mean x cubed over, okay, x cubed over 8. Okay, we will have this one, 0. Okay, 3t cubed. This one is your x. Okay, so from minus infinity up to 0 dt plus 0 up to x, 3 over 8 t square is your value for your PDF. Okay, dx dt. Okay, sorry, dt. So you integrate this one, you will get t cubed over 8. Okay, so gantikan x, so that's mean x cubed over 8. Okay, so you have x less than 0, between 0 and 2. Okay, so again, you have this one, fx equals to x cubed over 8. So the last one, you consider what happened when x greater than 2. So we will have fx minus infinity, okay, up to 0, 0 dt, okay, 0 up to 2, okay, this one, and plus 2 to some value of x, 0 dt, okay. Minus infinity up to 0, 0 dt, plus 0 up to x, 3 over 8 t square dt. Okay, so I got x cubed over 8. Okay, the last one, you need to consider what happened when x greater than 2. Okay, again, sorry. Okay, dt square dt. Okay, minus infinity up to 0, 0 dt, plus 0 up to 2, 3 over 8 t square dt, plus 2 up to x, 0 dt. Because the value of 3 over 8, x square is only defined between 0 and 2. So otherwise 0. So that means 0 dt for x less than 0. X greater than 2, here 2 up to x is also 0 dt. Okay, so that means this integration, you will get, okay, t cubed over 8. So 0 up to 2, this one you get total probability is equals to 1. So that means your capital Fx, okay, just write again, okay, is defined 0 when x less than 0. Okay, and then you have x cubed over 8. Salin balik dia punya range, and then you have the last one, 1 when x greater than 2. Okay, that is your cumulative distribution function. Okay, your capital Fx. So again, the last value here, you should get, if you integrate, okay, total, this one, you should get 1. Because total probability, ataupun dia punya integration over the range is equals to 1. Okay, again, capital Fx is given as x cubed over 8. So if you differentiate your capital Fx here, so differentiate x cubed over 8. So you will get back 3x squared over 8, which is your PDF, probability density function. Okay. So itu dia punya relation dia. Kalau kita differentiatekan cumulative distribution function, kita akan dapat balik dia punya PDF function, which is your small f. Okay. So dia ada tiga step lah ya. So if you have one range between 0 and 2, so you need to consider what happened when x less than 0. So when x less than 0, you have 0 density. So 0. Okay, next step, 0 and 2. Okay, minus infinity up to 0, kita ambil balik, tapi kita dah ganti 0. 0 up to x. Yang sekarang yang ada x ni kat sini, 0 up to x. So you replace 3 over 8 t square dt. So selesaikan x cube over 8. Okay, dia ada reason dia kenapa kita tak masukkan Or kita tak integrate from 0 up to 2 here. If you already integrate here 0 up to 2, you get 1 over here. Okay, kalau kita differentiate 1, 0. Tapi kalau kita punya small fx is 3 over 8 x square. So we need a function in terms of x. So that's why we just integrate from 0 up to x. Okay, you get x cubed over 8. So if you differentiate this one, you get back your PDF. So the last one, x greater than, x greater than 2, which is 1. Okay, so then you write in terms of function. Tulis balik. Capital Fx, x less than 0 is 0. Between 0 and 2 is x cubed over 8. And the last one, x greater than 2 is equals to 1. Okay, ada apa-apa soalan ke? Okay, boleh faham ke? Okay, okay, part 2 So you want to find 1 up to 2. Okay, 1 up to 2. Okay, so you can use either your fx because we already give you your fx, so you can integrate 1 up to 2. Okay, 3 over 8 x square dx. Dapatkan selesaikan. Or, since you already build up your cumulative distribution function. Okay, kamu dah build up ini. Kamu dah ada nilai dia. X less than 0, 0. 0 and 2, x cubed over 8. X greater than 2, 1. So now you want to find probability between 1 and 2. Okay, 1 and 2. You want to find probability 1 and 2. So you can use the concept F2 minus F1. Okay, where is your F2? Here. So F2, 2 cubed over 8. Your F1 is also in this range. So that's mean 1 cubed over 8. So again, you get 7 over 8. Okay. You can use either your cumulative distribution function to solve the probability, or you can integrate that 1 up to 2, 3 over 8 x squared dx. But use your PDF. Either one. Dua-dua boleh. Okay, because we already asked you to find what is your CDF with your cumulative distribution function, your capital Fx, and then you can use that concept, capital Fx, to solve for probability 1 up to 2. Okay? Okay, ada apa-apa soalan ke setakat ini yang you all nak tanya? Boleh faham ke? Okay. Okay. We look at the next example. Okay, task 3.15. Okay, we just have one range so far. Okay, nanti kita tengok yang ada dua range pula. Okay, again, so this one is already give to you is your cumulative distribution function. Okay, read the question carefully. So this one is your capital Fx. Okay, we want to find density function of x. You want to find that's mean density function, your small f. Okay, what is your answer for small f? What you need to do? You already give your capital F. You want to find your small f. Okay, differentiate. Good. Okay, so that's mean your small fx, you will differentiate. Okay, differentiate 0, 0. Differentiate 1, 0. Okay, now you differentiate this one, x minus 2 square over 9. So that's mean 2x minus 2 over 9. Okay. So tulis balik dia punya range dia. Okay, ataupun nak simplify lagi. Okay, tuliskan 0 fx. Okay, you have 2x minus 2 over 9, 2x less than 5, and then 0 otherwise. Otherwise, elsewhere, sama je. Okay, so this is your PDF function. Okay, based on your cumulative distribution function. Okay, so itu yang melibatkan one range saja. Maksud saya between 2 and 5 je lah. So again, we will look at what happen when x less than 2, what happen when x greater than 5. Okay, so now we have two range. Okay, task 3.16. Okay, task 3.16, you want to find what is your expected value. Expected value. What is your capital Fx? Cumulative distribution function. But you have two range between 0 and 1, 1 and 5. Okay, again, do it step by step. Okay, step by step sama je dia punya ni. Okay, first we start with what happen when x less than 0. Okay, you start, okay, let's see this one, x less than 0. Yeah, so x less than 0, your capital Fx. Okay, again, we will have, again, yes. Okay, minus infinity up to x. Okay, again, you will have, okay, 0 dt. So this one, 0 Okay, now you have 0. Kita copy back dia punya range tu. Okay, fx. Again here. Okay, you will have minus infinity, 0. Okay, 0 dt plus, okay, you have 0 up to x, okay, t square dt. Okay, ini first range there, 0 and 1. Okay, so you have 0 up to x. We use different variable, which is t square dt. Okay, so this one should give you 0. And then apa? T cube over 3. Okay, then substitute 0x. So x cube over 3. Okay. So again, next step, 1 and 5. So 1 and 5. Okay. So fx, again, you will have from minus infinity up to 0, 0 dt, 0 up to 1, t squared dt. Now 1 up to x, 5 minus t over 12. Okay. Selesaikan dia punya integration dia. Okay, so this one you have t cube. Okay, t cube over 3, 0, 1 plus okay, so cuba selesaikan apa dia punya ni. So again you will have apa tu? You have 1 over 3. Okay. 5x over 12 minus x squared over 24. So minus with 5 over 12 minus 1 over 24. Okay, cuba simplify kan. Okay, what do you get? Do you get? Sudah baca Kalau let's say saya salah. So you have minus 1 over 24 plus 5 over 12x minus x squared over 24. Okay, so that one is between 1 and 5. Okay, so you just integrate minus infinity up to 0, plus 0 up to 1, plus 1 up to x. Okay, so selesaikan. And then you have minus 1 over 24 plus 5 over 12x minus x squared over 24. So again, if you want to check whether your value is correct or not, so you just differentiate this one. Okay, so 5 over 12x, differentiate this one, you get 5 over 12. Okay, minus x squared over 24, again, you get minus x over 12. So we got back lah, dia punya small fx. So yang tadi pun sama ya. If you differentiate x cubed over 3, okay, you will get back your x squared. Okay, the last one, x greater than 5. Okay, x greater than 5. Even though you know the answer should be 1, but again, write down the method. Okay, so that means we will have, okay, so minus infinity 0, okay, plus 0 up to 1, t squared dt, plus 1 up to 5, 5 minus t over 12 dt, and then the last one, plus 5 up to x, 0 dt. Okay, solve your integration, and this one again will came out as equals to 1. Okay, tunjukkanlah dia punya jalan kerja, jangan simplify tulis dia punya itu equals to 1. Tunjukkan how you solve your integration and then how you get your equals to 1. Okay, so now kita simplify balik semua. You have capital Fx. Okay, capital Fx. Okay, so again, you have 0 for x less than 0. Okay, x cubed over 3 for 0, x 1, and then we have minus 1 over 24. Then the last one, you will get 1, x greater than 5. Yeah, so this is your cumulative distribution function. Okay, double check, cuba differentiate balik. Dapat tak balik dengan dia punya small fx tadi. Okay, so that is part A. So build up your cumulative distribution function. So part B, you want to compute the probability. Okay, for part B, okay, for part B, you want to compute probability x less than half. Yeah, so probability x less than half. Okay, let's say you want to find using your cumulative distribution function. You don't want to integrate. Integrate mungkin panjang sikit. So, dapatkan probability x less than half. So, half is located in your second range. Okay. So, that means you will have minus f 0. Okay. So, again, if we substitute here, x cubed over 3. Okay, so you solve this one. So, 1 over 8. So, you get 1 over 24. Okay, dapat. So, that is your probability for x less than half. Okay, if you don't want to integrate. So, kalau integrate pun, that means you will integrate from 0 up to half x square dx. Sama je. Kalau ada x cube over 3, gantikan balik. Okay. So the next one, probability half x less than 2. Okay, again, for this one is a continuous distribution. Either having equality or without equality is the same thing. So what you need to do is solve half less than equals to x less than 2. So check dia punya range tu ada kat mana. Okay, kalau half, maksudnya dia berada dekat first range. 2 berada dekat second range. Okay, ataupun kalau let's say kita tulis dalam bentuk dia punya integration. So you will have half up to 1 x square dx. And then you will have 1 up to 2 5 minus x over 12 dx. Okay, ini kalau kita integrate. So the same thing. So that's mean kalau let's say kita nak ikut yang ni, maksudnya F1. Okay. So F1 minus half. Okay, plus kat sini F2 minus F1. So it's the same thing if just write F2 minus F half. So gantikan nilai dia. F2 minus F half. Okay, boleh eh? Kalau let's say kalau saya splitkan into integration, so you will have half up to 1 plus 1 up to 2. Okay, so by writing into probability A less than X less than B, so FB minus FA, so F1 minus F half plus F2 minus F1. So, or you can simplify by writing capital F2 minus capital F half. Okay, so maksudnya gantikan balik F2. So you have 2 cube over 3. Gantikan dengan F. Tadi apa dia? Sorry. F2. Sini. F2 gantikan kat sini. Minuskan dengan F half tadi. So kita ada that one lah. Okay, half cube over 8. Then you get your answer apa. Okay, ada yang dah selesai kan? Boleh bagi apa dia punya last answer dia. Apa tak? F2 kamu gantikan dekat sini. So F2 which is minus 1 over 24 plus 5 over 12 times 2 minus 2 square over 24 minus F half. So half cube over 3. Okay, again you check lah your probability. Kalau let's say double check cannot exceed 1. Okay, kalau lebih daripada 1 mungkin salah dari segi calculation tu. Okay, itu dia punya konsep eh. So either you can use your small fx, which is your probability density function, or you can use your capital F, your cumulative distribution function. Betul Syuhada. So F2 tu you masukkan. So maksudnya bukan bukan Syuhada sini. Guna yang ni. Jangan tersilap pula. Okay, so ini guna yang ni capital F ni. Allah. Guna ni. Okay, sebab yang small f kamu tu x square 5 minus x over 12. Okay, kalau kita nak gantikan terus without integrate capital F2, kamu masukkan dekat ni. Maksudnya kat sini F2 ni. Okay, so F half masukkan kat sini. Tapi kalau kamu nak integrate your PDF, yes betul, second equation. Tapi, ni tadi saya tuan. Okay, tapi kalau let's say if you want to use your integration, masukkan yang fungsi yang pertama. Sebab ini PDF kamu ni. Ini PDF. Okay, yang ni CDF. Kalau nak guna direct, sebab kamu dah build up kamu punya capital F ni. So, kamu nak gantikan F2. So, masukkan sini F2 minus 1 over 24 plus 5 over 12. 2 minus 2 square over 24. Then you get berapa? Betul F half pun gantikan sini juga. Lepas tu, tolaklah nilai dia berapa. Okay, itu kalau kita nak pakai cumulative distribution function. Sebab kita dah build up dah pun cumulative distribution function. So, tak ada point kalau kamu tak guna. So, better you use your capital F instead of you integrate. Kalau integrate pun, benda yang sama juga. Kamu akan masukkan balik dia punya value tadi. Okay? Ada yang dapat jawapan tak? Kita compare the last answer. F half tu masukkan dekat ni. Second equation, Haris. Sini. So, kiranya 1/2. Okay. 1/2 cube over 8. Over 8, over 3. Okay, so 1/24 lah. Okay. So, again, you get F2 tu dapat berapa ya? F2 kalau nama gantikan? So, sekejap ya, saya kira. -1/24. Okay, KW 0.625 F2 KW. So, I just take KW answer 0.625. Ke itu last answer ke apa ke? Is it for F2? Okay. So, 0.25, 0.625. F half tadi berapa tadi? Kita buat 1/24 kan? Okay. 1/24 kalau kamu nak tukar berapa pecahan? 0.0417 lah. Okay, so you get the answer. Baik kan? Again lah, dia punya biasanya yang careless mistake tu bila kamu nak gantikan value ni. Okay. So, kamu dah solve kan, you already have your fx. Kamu check lah, either this one give you a cumulative distribution function or your small f. If this one give you a small f, so that means you need to find what is your capital F. Okay. So, set up your distribution function. So, in order for you to find the probability, you also can use the cumulative distribution function because you already derived in A. Or if you want to integrate your PDF. Okay. Sebab this one is two range, mungkin agak complicated sikit lah. Not complicated lah dia punya value tu. Okay. Kalau one range tu, maksudnya kat sini kalau kamu nak build up, okay, you only have 3 step. Okay, from 0 up to 2. So what happen when x less than 0? Between 0 and 2, x greater than 2. Okay, kita ada 3 lah step. Okay, tapi kalau kita ada 2 range, okay, so what happen when x less than 0? Between 0 and 1. 1 up to 5, and then the last one, x greater than 5. And then write down what is your capital F. And use this capital F to find the probability. Okay, so satu lagi yang biasa student careless mistake adalah ialah tanda equality signs tu. Okay, let's say if you want to find probability x less than or equals to, ataupun probability x less than 1. Maksudnya kamu tak perlu tukarlah probability x less than or equals to 0.9. Okay, because this one is continuous. So again, probability x less than 1. So you just integrate lah from 0 up to 1. Okay, either having equality or without equality, it is the same thing. Because the reason continuous cannot take exact value. Okay, dia tak ada nilai. Probability x equals to x tu, dia akan jadi 0. Itu yang kita katakan continuous. Kalau if you furthermore study lah kalau let's say for maths student nanti, siapa nak join maths, you will learn how the concept for continuous function sebab tapi kalau kamu belajar limit dalam, saya pun tak sure lah yang kamu belajar dalam foundation tu apa. Okay, sebab kalau kita ada macam mana saya lukis katakanlah continuous function macam tu kan. Okay, dia punya ni. Maksudnya sini kan. Okay, limit daripada kanan ke kiri tu sama. Okay, so limit dia punya limit. Apa yang saya pun tak ingat. X approach A positif katakan. Apalah dia punya fx kan. Macam itulah FA. Okay. So limit daripada kiri. Okay. So katakan ini pun kita dapat FA. So FA tu minus that one, you get 0. So that's one, if you have a continuous point, probability X equals to A. So this one is equals to 0. Okay, for a continuous function. Dia lain. Ini continuous kalau kita draw this one, kalau saya bagi graph sini kan. Ini discrete. Step function. Ini kita panggil sebagai step function. Sebab dia akan jadi value yang lain-lain macam between 1 and 2 you have one value. Between 2 and 3 dia ada value. It's the same thing. Okay, ini macam kalau yang ni smoothing function. Smoothing curve is a continuous function. Okay, so itu beza konsep how matematik ni kita integratekan sekali dalam konsep statistik. Statistik kamu nak dapatkan probability. Okay, tapi kalau matematik tu kamu nak tengoklah dia punya limit and so on. Okay, so that's why we also have a course on mathematical statistics. So that's mean the knowledge that you already learn in mathematics, we will adapt it in statistics punya concept. Okay, mathematical statistics